Hey guys, this is Jeremy Day. The new people might not know him. He's our former vice president, well-loved graduate student friend here. He's been here for 30 or 40 years at this point. But he's going to be talking to us today about Rust. And yeah, really excited for you. Put a lot of work into this.
All right, thank you. So just on the starting slide here, this is the Rust logo. You may notice my shirt also has the Rust logo on it. I'm a huge fan of Rust. This over here is Rust's unofficial, not official unfortunately, unofficial mascot named Ferris, which is of course a pun on like a Ferris medal. And the species of Ferris is a rustacean, which is what Rust programmers like to call themselves. I don't use the word too often, but you see it all over the place, so you gotta learn to love it. Okay, so I have some examples of code, syntax, other things. If you want to follow along, it's on my GitHub, github.com/zto/rust-examples. So I'll give everyone a second to do that if you want to. Most of the code and stuff will also be in the slides, or I'll go over it. So don't feel like you have to do this if you don't have your laptop. Okay. So this talk's going to be two parts, and what this may end up being probably is what it's going to end up being is be two different talks. I tested this entire presentation out on Monday, and it was like 95 minutes long, which is a bit out of scope for one of these, so it might be better to cut it up into two more digestible pieces. So the first part, which is what I'm going to do today, is going to be Rust tooling, the Rust ecosystem, documentation, and the Rust community. Rust is really interesting in the sense that it is an incredibly modern language, and all parts that I've mentioned here are completely endorsed by the core Rust team. And I'll get into more of what that means and what that means for the language as I go through my slides. Part two is going to be code. So this is going to be code examples, features of Rust that make it better than every other language you've ever heard of, etc. All right. So first of all, what is Rust? This is taken straight from the Rust website, which is rust-lang.org. Rust is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. So I'm going to go into what these mean a little bit. Rust is blazingly fast. So when people think of a fast programming language, most people think of C. It's pretty much the fastest programming language that you can write code in. Rust is very close to being as fast as C. It's within about a factor of 2 of the speed of C, sort of out of the box, and you can optimize your Rust code to really reach almost the same performance as C. In reality, programs written in Rust often end up being faster than programs written in C for reasons that I'll get to in a bit. Rust prevents seg faults. This is sort of the big feature of Rust is it's a safe programming language, so you can't like exceed the bounds of an array. If you're indexing, you can't dereference null pointers, you can't get data races, you can't try and use a resource after freeing it. These are all issues with C and C++ that Rust does not have. The best part about it is that Rust gives you these features for free at the compilation step, so you don't pay for them at runtime, whereas a language like C# or Java has a garbage collector that gives you these big performance spikes every now and then when it frees up all the memory that you're no longer referencing. Rust, C, and C++ don't do that. They leave you responsible for freeing up your memory, but Rust kind of does it for you as part of the compilation step. It guarantees thread safety. So back when C was made in like the 60s, sometime around there, 40-ish years ago, every CPU was one core. They didn't really have multi-core CPUs, so they didn't really have programs running on multiple cores at the same time. So concurrency wasn't really a concern when they were writing C. And there's libraries for it now that can help you run concurrent programs, but Rust was started very recently and has that baked into the language. It started as a Mozilla employee's personal project in 2006. It was this guy, Graydon Hoare, who started it, and it was sort of just like a pet project of his until in 2010, Mozilla officially sponsored it as a language that they wanted to push forward with. And the Rust compiler successfully compiled itself in 2011, which is kind of like the really core birthplace, I feel, of a compiled language. And this is another great thing about Rust. It's 100% open source. This is the repo for the compiler. It's on GitHub. They accept pull requests. You can file an issue if you find a bug or have a feature request. It's very, very cool. The Rust community is super open. All right, so Rust is a pretty new language. It came out in 2010, 2011, so that makes it around 7 years old. So typically when a language is this new, nobody's using it, right? Because it's not mature enough, there's not library support, there's not documentation out. So companies tend to stray away from using these in production. But Rust is different. So I'm going to have a list of projects here. The thing on the left is the name of the project. The number in parentheses is the number of stars it has on GitHub. So Servo is a program written for Firefox. I believe it's the layout engine for Firefox. No, I think Servo is the replacement.
That's what I said.
Oh, yes.
It replaces Gecko.
Right, it replaces Gecko. So it's the next generation of layout engine for Firefox. Quantum, which is their CSS styling engine. And I think Quantum actually came out last November as part of like the Firefox Quantum update that was controversial for reasons that did not involve Rust. And it sped it up, I think, by like a factor of 2. They rewrote the whole thing in Rust. ripgrep, which is the fastest file searching program known to man. So if you've used grep, then ripgrep's very similar. You may have heard of the Silver Searcher, which is a rewrite of grep in C. ripgrep is faster than the Silver Searcher. It is the fastest file searcher out there. If you use, yeah.
So is that like I just install that on Ubuntu or whatever?
Yep. Sudo apt-get install ripgrep.
Are the flags the same as grep?
I think it's a drop-in replacement, and it's invoked with RG, so it's one character fewer when you're typing it.
Just set an alias then.
Yeah.
Right.
I'm not sure if it's 100% interoperable, so if you're writing like a shell script, you should probably still use grep instead of ripgrep, because grep is just completely universal. But if you use like VS Code editor, when you press search through project and type in something, it's using ripgrep in the backend to make it that fast. EXA or EXA, I'm not sure how it's pronounced. This is a replacement for the ls utility. It's written in Rust. It's much faster than ls is. XI is a modern text editor by Google, and I don't think it is like released yet. It's still sort of in the development stages, and it already has 13,000 stars, which is absurd. And it is written in Rust. And XI, of course, is similar to VI in its spelling.
Z.
I think so, but I'm not sure. Xi? Is that it? Yeah. Alacrity is a terminal emulator, kind of like Console or Termite, or what's the Ubuntu default? Ubuntu, yeah, whatever it is. But Alacrity is the fastest terminal emulator out there. It's not just because of Rust. It uses like hardware acceleration to actually render the terminal, which is why it's so fast. But it is written in Rust. Redux is an operating system written in Rust. And this is not an operating system like Ubuntu or Arch Linux is. This is a complete, they wrote a kernel in Rust. They wrote every feature of the operating system in Rust. You can boot to it today. It is available. It's not feature complete. You should not use it as your primary OS, but it is available on GitHub and you can boot to it. Yeah.
It's very difficult to get started. You have to compile it from scratch. It has its own custom compiler.
Yeah.
It's a pain to install.
Yeah, I would not use it, but it is kind of exciting that eventually you can use a computer that is running 100% Rust code, which is something that we should all strive for. Dropbox uses Rust internally. I think it's what they use to like process file transactions. They do something like a few petabytes of data per day are going through their Rust code. They wrote a blog post about it, which has a lot more information than I could give you. NPM uses Rust for a similar function. I think it has something to do with managing their package registry. Basically, if you're handling huge volumes of data and you need your code to run fast, and you don't want to worry about memory leaks or having your code crash in production, you can use Rust. Rust maintains a list of their friends here, which is a ton of other companies that are using Rust in production today. And a lot of them are links to blog posts about how the company is using Rust, which is very interesting to read. Yeah?
Are there any languages that have the option to like compile to Rust? Say like Python or like...
Not that I know of. I'm not I haven't looked into that though. I wouldn't be surprised if there are, but I'm not aware of any as of yet. All right, so at this point, hopefully you're asking yourself, well, how do I use Rust? Because you've seen how many other people are using it for great success. Well, the Rust team made this incredibly easy. rustfmt is a program that will install Rust for you and manage your Rust installation. You can go to rustfmt.rs on a web browser, and it will just give you this shell command. You just put this in your terminal, run it, and then you have Rust installed. It is very, very easy. Or if you are using a Linux distro, you can probably just use a package manager to install rustfmt. That's what I did. But this works just fine. Rust runs on about everything you can think of, including ARM, iPhone, Android, I don't know, other obscure architectures, but it'll run on everything, and you can code on Rust on Windows as well. It's completely cross-platform. So I'm going to give everyone a second to type in the shell script if you want. Or if you would like to copy and paste it, rustfmt.rs. So I can actually show you. Well, I won't show you because people are writing this. But it is literally, this box is all that's on the website. And you can just copy and paste it from there. Okay. So first of all, I'm going to talk about the tools in the Rust ecosystem and why Rust is so easy to use. So the most important tool that you'll be using when you use Rust is called Cargo. Cargo manages Rust projects and allows you to install dependencies, execute your project, build your project. In fact, these are all bullet points, so I'm just going to go through here. And so now I have some live demos that you can join along with. So this is the GitHub if you've downloaded this. All right. So we're going to go into the cargo init folder. You'll notice this is just an empty folder. And when you want to start a new Rust project, and so let's say we want to start a binary project, so you can write Rust libraries or Rust binaries, but we'll do a binary. You can do cargo init --bin, press enter, and you have a Rust project set up. So each Rust project has a source directory, which is, of course, all your source files. It has a cargo.toml? Anyone know?
I would say
toml? Okay, cargo.toml file. This is a configuration file for your project.
Is that 2 markup language? 2ML?
yeah.
2ML?
Yeah, so it's probably toml actually.
Toml? It's
Very
Thomas's.
similar to YAML.
Yeah, okay. Cargo.toml. And then I'm already in the Git repository here because of my Rust examples Git repository, but normally when you do cargo init, it automatically initializes a Git repository in that folder for you to use, which is super convenient. Oops. So now we're going to walk through installing a dependency. Rust is, in terms of the family of languages, it's most similar to C or C++. So if any of you have used C or C++, you may know how much of a pain it is to install and manage dependencies. There's really no versioning. You just sort of download a header file and point to it and cross your fingers. Huge pain. You don't have to do any of that with Rust. If you've used like JavaScript or the Node package manager, it's a much more akin to that experience where you just sort of find a package and put it as a dependency and it'll just work. And so I'll demonstrate this. I have some tabs up here. You can go to crates.io, and this is the package registry for Rust. And so with NPM, it is maintained by people who are not affiliated with JavaScript, and they've run into some issues recently. I don't know if anyone follows like Hacker News or R programming. I have not seen any issues with Cargo so far, so it is very reliable. And it is made by the Rust team. It's just a huge list of Rust packages, which are called crates, and you can search through them. So I'm going to walk through installing the image dependency, which is how you load in and parse images. Yeah.
Can anyone put a package on here, or does it have
Yes.
to go through like a approval process?
You can publish your own packages on Cargo. I haven't done it, so I don't know the process, but I think it's not that hard, and I don't think there's a approval process. But typically you're going to use packages that are more popular, so you kind of know that they're legit because of their popularity. I think it's very similar to NPM in the way that they manage that. So you can click on a library and it'll load it up. Right here it tells you what to put in your cargo.toml file. So we're going to copy that to the clipboard. We're going to open up cargo here and paste it as a dependency. And then if we run cargo build to build our project, it's updating the package registry. Well, that's not good. Something's wrong with my certificate authority. Anyway, this should work for you, where it will then just download all of the packages and, more importantly, all of the dependencies of those packages and compile them for you on your machine. It's super easy.
I ran into this. Apparently the SSO certs changed recently, so you have to run apt update.
I have to run what?
apt update. Or whatever.
Oh. Okay, well, I'll run that in a different terminal while this is going. Hold on. Yeah.
So, and I apologize if this is something you were going to answer later, but so I and maybe other people in this room have used tools like Maven before, which kind of is the same thing but for Java. And one of the problems with this particular model of dependency management is that you go on the library that you're using's website and they say, oh, copy and paste this into for Maven it's pom.xml, not cargo.toml. And then what happens is now your code is pegged to only use that version, which means if you download it and run it or compile it 10 years later, it's still pulling down the version that it had when you set it up. Does Cargo have facilities to go, give me at least this version,
yes,
but whatever the latest one is?
Yeah, so normal semantic versioning scheme, if you've used NPM, you'd be familiar with that. So I can write, for example, instead of a specific version, I can write star here and it'll just pull the latest version. Typically this is not a great idea because the way semantic versioning works is if you increment that first number, it means you have breaking API changes, so your code could stop running at any point.
But presumably you could do like $1.star or something.
Right, and it would pull from just that semantic version. I wish this would work so that I could show you what happens. Oh, you can see it right here. So the cargo.lock file is not very parsable, I don't think. But the cargo.lock file indicates which version of each package you used, so that later, 10 years, if you want to recompile your project, it'll actually use the same version of the dependencies you used to compile previously, instead of grabbing the latest version, which is a good idea for binaries like this. But it does have semantic versioning, which makes it really easy to use. All right, so I'm actually going to remove this dependency so that I can show y'all the build step. So one bad thing about Rust that you'll learn is the compilation time is incredibly slow. So 0.88 seconds for hello world is like pretty bad in terms of compilation. And you may notice finish dev unoptimized plus debug info. By default, Cargo will compile an unoptimized version of your code because it takes so long to compile an optimized version. It probably won't take much longer in this case, but you do cargo build -- release to enable the optimizations. It actually finished faster, so that's a terrible example. But normally it takes much longer. This is an issue for a lot of people. So I read a blog post about a game developer who was writing in Rust, and he said at one point it got to where his compilation time was 15 minutes. So he would, and with a game, you can't really test the unoptimized version because you'll get terrible frame rate. So he would compile, test it, his character was jumping too high, he would tweak the jump parameter, hit compile again, and 15 minutes later he could test again. So that's a real problem. Rust just added incremental compilation like 2 weeks ago. I don't know if it's available in the stable version yet, but basically that means if you change a file, it only has to recompile that one file instead of your whole project, which is obviously going to speed up compile times a lot. But that is a big problem with Rust. Yeah?
Isn't isn't that sort of not a feature of the language, but built in the idea of Rust?
Yes.
That like it might be an issue for somebody personally, but if you use Rust, using with the understanding that the reason it can be so fast is you're compiling. So
Exactly. Yeah. So basically, the big thing about Rust is it offsets all of the time into the compile phase instead of the run phase. So you're paying that cost up front at the compile phase, but then you can run your application a million times and it'll be blazing fast every time. If you compare that to like an interpreted language where you don't get that optimization right up front, it runs much more slowly after you or while you're running it. Then the way you run a program is cargo run, and you can see it prints out hello world here. Cargo run, oops, release will run the optimized version. In this case, there's just really no difference because it's doing such a simple computation, but for large programs, the optimized version is much, much, much faster. Okay, so another great thing about Rust is it has unit testing built in. So how many people have heard of unit testing? Okay, so in industry, hopefully whatever program you are working on will have unit testing. And this is to make sure that as parts of the program change, the core functionality does not change. So you don't introduce bugs. It's a way of keeping bugs from being introduced. So I can open up main.rs here. And don't worry about all this syntax. It's kind of a lot. But basically you can define a tests module, give it this code here to configure it for testing. And then you write functions with the, I'm not sure what these are called, attributes maybe? With the test attribute. And then it will run these functions as tests. So right here I just wrote a simple function to take in a number and square it. And here I'm testing that the square of 2 is 4, the square of 10 is 100, the square of negative 1 is 1. Down here, if you try and square the maximum 32-bit integer, it should throw an error because you'll get integer overflow. So this directive right here saying that this function should panic. A panic in Rust is like a crash. You don't want your program to panic. So this is saying that this test should panic. We want it to crash there. And then all you have to do is run cargo test, and it will run your tests for you and let you know if they passed or failed. So I don't know of any other languages that have testing like this built into it. I'm probably wrong. I'm sure there's another new language that has it built in, but with like Java, you have to use JUnit. With C and C++, I have no idea what you use. JavaScript's got 15 frameworks for testing, but in Rust, there's one. It's built into the language. It's built into the package manager. If you install Rust, you have the ability to test, which is awesome, super helpful. Also, if we want to go to the cargo modules folder, you can install modules to cargo, which sort of enhance the functionality of cargo or let you do other things on your code. So in here I have a install modules script, which will install two modules, clippy and rust format. So rust format, as you might be able to guess, formats your code. So if I print out this line, you can see the print line is indented one extra. And if I do cargo, I think it's just rust. No, that's not what I meant. Oh, it's format. Then it will automatically format my code. I can print it out again, and you can see it fixed the indentation error. I have my Vim set up so that when I write a file, it automatically runs Rust format on it. So my code always looks how the Rust devs intended it to, which is super nice. Also, does anyone want to take a guess what this line of Rust does?
Is it the return value?
I know where you're getting at, but no, it's not. Anyone?
Throws an error because it's immutable.
Has anyone seen this before? What this does in like another language? It's decrement. It's pre-decrement operator. There is no pre-decrement operator in Rust. But this does not throw an error because what you're doing is you're negating the negation of a number. So this expression just returns X, right? So if you're coming from C or C++, which is what Rust programmers are intended to come from, then you might look at that and get confused. Or worse, you might try and write that in your code. So this is where a tool like Clippy comes in handy. So Clippy is a linter for Rust. If you've ever heard of a linter, basically it statically analyzes your code, looks for common mistakes, common bugs that are not necessarily compiler errors. So we can run cargo Clippy, and it will tell us right here, --x could be misinterpreted as pre-decrement by C programmers. It is usually a no-op. So of course the compiler doesn't actually negate x and negate it again because it's smarter than that. It just does nothing on that line. But it is clearly not what you intended to do. However, it is valid Rust code, so the compiler won't error on it. So you can use Clippy to catch those kinds of issues in your code. Okay, back to the slideshow. So now we're going to talk about rustdoc. In any language, documentation is hugely important, and none of them really have, as far as I know, documentation standards built in. C# might, but JavaDoc, is that made by the Java team, or is it a third party? Because like JS Hint is third party for JavaScript.
JavaDoc from the team.
From the team? Okay, awesome. So JavaDoc's probably extremely similar here to rustdoc.
Also Python.
Python does it as well?
They have a first-party one. It's one of the PEPs. I forget what PEP number it is, though.
Okay, awesome. So other languages are doing this, which is good. Rust has it as well. It automatically generates HTML documentation based on the documentation you write in your code, and inline markdown in comments is supported. So I have an example of this as well in the rustdoc folder. So I think the format is cargo rustdoc, and you can do -- open to automatically open it. Yeah, it opened on my other screen, but I'll also show you what it looks like. If I can, there we go. So you write your documentation like this. So here's a simple function that increments x by 1. Markdown is supported, so if you've used Markdown before, you'll know that the # here means this is a header. 3 backticks mean code. And so then if we look at what just opened up in this web browser here, you can see it puts out this really nice documentation for it. It's completely interactive. I can click on this. It'll show the code I wrote in the examples, and everything is super nicely documented. This is invaluable for third parties when they're writing libraries and stuff. All the documentation looks like the standard libraries documentation, and it makes it super easy to write good docs. Yeah?
Can you show the original code again that it generated this from?
So it's super easy. All of this is interactive. I think I can search for stuff up here too, and it'll, yeah. So incredibly handy. Super easy to write documentation. Now there's no excuse to not write documentation. In fact, I'm pretty sure that you can, I think this is third party, but there's a third party package that exists where you could write your unit tests in the examples, and it'll run these as unit tests, which is super cool. Okay. All right, so I'm going to talk about the Rust community, which is one of the best features of Rust, even though it actually has nothing to do with the language itself. So the Rust IRC channel is an incredibly helpful group of people. It is the official Rust communications forum. Again, everything I'm talking about is from the core Rust team. The entire Rust ecosystem is developed and maintained by the core Rust team, so you know all parts of it work really well together. And yeah, so the Rust IRC channel is super helpful. There's also a Rust Beginners IRC channel where you can go and ask any question you want. I've probably asked half dozen questions here. People are incredibly nice. They'll walk you through everything, give you links to great documentation, great resources. Super awesome community. The Rust subreddit is amazing, and I'm actually going to show it right now if I can. Every week they do do you have an easy question thread? You can post in here, ask your question. People will look over your code. They'll do code reviews. They'll tell you what you're doing wrong. They'll help you solve bugs. They do community outreach events like this. What's everyone working on this week? This guy is a moderator of the Rust subreddit, and he wrote Clippy, which is the thing I showed you earlier. I think he's on the core Rust team. And then people just put great links to blog posts, new packages, things that people are working on. It's a really cool community. And then the Rust language developers themselves maintain a list of community outlets. So there's official Rust forums. There's like 30 Rust IRC channels for specific packages or features of the language. There's a IRC channel for working on the compiler if you want to try and work on the compiler. Yeah.
On Reddit, there is like a post about interoperability with C++. How does that work?
I will get to that. Maybe not today. That might be in Rust 1 and 2. But I'll go ahead and say now, Rust is 100% compatible with C code. You can call C functions from your Rust code. You can call Rust functions from your C code. And this is one of the big reasons why Rust has grown so fast as a language, is a lot of the Rust libraries out there are actually just Rust wrappers around underlying C libraries, and they slowly rewrite one function at a time to be in pure Rust, which gave the language a huge jumpstart of being able to do a lot, because you can really do everything you can do with C. You have access to the same libraries. Okay. So everything, documentation is really great in Rust. I already showed you how to generate your own documentation. The standard library is incredibly thoroughly documented by the Rust team, and I'm going to show some of this because it's absolutely incredible. Yeah, so doc.rustlang.org/std is the standard library. This talks about the standard library crate. Let's search for like iterator, and it's got the implementation of iterator, and then just tons of examples, really thorough documentation on every function, what everything does. It's an invaluable resource. Whenever I'm writing any code in Rust, I have the documentation pulled up right next to me, and it's super easy to search through and go through. Everything's super organized. So the documentation of the standard library is a huge boon to the language. Additionally, docs.rs for free will host your documentation for your crate that you upload to cargo.io, which I talked about earlier. And in fact, they do it automatically. So if you upload a crate to cargo.io and crates.io, and you have that documentation in line that I talked about, docs.rs will automatically pull your crate down, generate your documentation, and then host it for free on their website. So if I go to docs.rs, you can see 1 minute ago someone updated the OpenSSL package and they just generated the documentation for it. And if I search for like the image crate, for example, which is a dependency that I installed earlier, right here I can click on this and it's got all of the documentation for the image crate right here. So the documentation community around Rust is incredible and makes it really easy to start writing with new libraries and start learning the language. All right, so now let's talk about learning the language. So Rust is notorious for being incredibly difficult to learn, kind of like C and C++, where there's sort of a high learning curve and there's a lot of issues with like manual memory management. The thing about C and C++ though is the compiler will happily let you make mistakes, so it's slightly less frustrating, or at least the frustration is delayed to runtime instead of compile time, when you start getting seg faults and have no idea what the hell is going on. So with Rust, it's very hard to placate the compiler, but once you do, you're not going to get any seg faults. But a lot of people get frustrated of writing code that just won't compile, and it turns a lot of people away. So this is actually one of the biggest things that the Rust team is working on, because the future of the language depends on people coming to the language. So they actually wrote a book on learning Rust. For most languages, I believe there's probably an official book or official resource in some capacity, but this is sort of the de facto Rust resource. And again, it's written by the core Rust team, which sort of verifies that it's going to be quality. So this is commonly referred to in the Rust community as the book, and it's probably the best place to go to learn about Rust. I think they just finished the second edition of the book, which is a big improvement over the first. It's something like 20 chapters. It's pretty long, but if you read like the first 4 or 5, you'll get a pretty good introduction to the language and be able to start writing some Rust code. The community is a great learning resource. So I already talked about that some, how the community was incredibly useful in asking questions and providing you with help, and you can leverage that. So if you run into an issue, go on Reddit, go on IRC, ask someone about it, and someone is going to help you out. Rust recently went through something called the impl period. I think it's ended, but you may still be able to participate. So find something Rusty to work on. They have a huge list of starter issues in the Rust ecosystem where people are offering to mentor new Rust programmers on how to help contribute to Rust programs. So these are relatively easy issues that for these people probably would not take them much time to fix. But instead of fixing the issues themselves, they decided to let this be a way to bring new Rust programmers into the community. So you can go on one of these GitHub issues and say, hey, I'd like to work on this. Can someone mentor me? And someone will give you their email address, and you can start talking to them in an email chain. And they will review your code, make sure everything works well. Obviously, they're not going to let you push bad code into the repository. But if you're interested in learning Rust, this is probably the best way to do it. You have a verified expert helping you with every step of the way. So compiler errors, this is serious. The compiler errors in Rust are phenomenal. They're formatted well, they are descriptive, they have your code written out where you messed up, not just the line number, they actually print out the line of code and some surrounding lines. They're really, really good compiler errors. And usually they'll say, did you mean to do this? And probably 90% of the time, you can just copy and paste the code that they paste in their compiler error, put that as your code, and then it'll work. And I have an example of what I mean here in the, where is it? Errors. So this code will not compile. So they give you the error number, they tell you what's wrong. In this case, X does not live enough. They print out the code. They say right here, the borrowed value does not live enough. It needs to live until here. It's dropped right here. It's okay if you don't understand what that means. That's part of the Rust ownership system. But it's really, really good compiler errors. And if you get an error like this, so E0597, and you want to learn more about it, you can type rustc, which is the Rust compiler. Whoops.
I know you don't want to go into that exact area, but is traditional encapsulation not in Rust? Like was that like a variable declaration or like a scoping issue? Or?
No, it's a lifetimes issue, which is the weirdest and most important feature of Rust, which we will probably get into next time. So you can type rustc, I typed cargo. Explain E0597. Oop. And it will take you into an example of what it is, how to fix it, what the issue is in more detail. All of this is available offline. It's built into the compiler. It's awesome. Pretty much any error you're going to run into, you can read one of these, and at the end you'll know way more about Rust, and you'll be able to fix your error. So compiler errors are actually a really good resource for learning Rust, and you will get lots of compiler errors. But once you fix them, you won't get any seg faults, so it's worth it. These last two are just two other resources for learning Rust. So this GitHub link right here is just a massive list of resources to learn Rust. And I mean, it is just huge. And they are organized into learning about like iterators, learning about lifetimes, learning Rust from a C# background, learning Rust from a Python background, how to do testing with Travis CI. I mean, it's tons of resources here to learn Rust. One that I recommend in particular is the into-rust.org .com screencasts. So they do nice short video tutorials on a few basic aspects of Rust. The biggest ones are ownership, shared borrows, and mutable borrows, which are sort of the more difficult concepts to learn in Rust. These videos are made by one of the lead developers of Rust. Again, you know that it's good because it's made by the lead developer. So they've made learning Rust a lot easier than it was, 6 or 7 years ago. It's a great time to start learning about it. All right, how am I doing on time? 7:50. Okay, we're gonna go through just a little bit of the syntax, which will be a good stopping point for today. All right, so in this file, in the syntax folder in the Rust examples, I just have some of the basic syntax. If you're familiar with C or C++, it probably won't frighten you very much. A lot of the syntax is similar, although they switch out some keywords for some trendier ones. So comments are just like they are in C. You can do single line with // or use the /* to do multi-line comments. The main function is, of course, the entry point to your program. Functions are declared with fn, and then the name of the function, the arguments, and then you open your scope. You use the let keyword to define variables. So here we have let x equals 5. Rust is a very strongly typed language, but it has great implicit type detection. So it can tell that the type of x is going to be like an integer, because I said x equals 5. I can change this to 5.0, and now x is a floating point number. Of course, you can specify the type. You do this by putting a colon after the variable name and then specifying the type there. So this is an unsigned 32-bit integer. If you're used to using int, for example, or float, the names are much more descriptive. So for example, I32 is a 32-bit integer. I64 is a 64-bit integer. I128 is a 128-bit integer, and I think on certain architectures you can go up to I256, which is kind of absurd. Also, for floating point, you can do 32-bit floating point number or 64-bit floating point number. Yeah.
The I up to 128, are those signed?
Yeah, and then you can do unsigned with U. Yeah. So with C, if you have I equals a number and you increment in a while loop, your code will never stop. Excuse me, if I is an integer, because once I reaches max int, it happily loops over and becomes negative max int, and then we'll loop up through the negative range. Rust doesn't do that. It's got bounds detection, so you can't go over or you can't go under, which is very helpful for some particularly tricky bugs. So for loops are actually just syntactic sugar. They don't compile to what you might expect a normal for loop to be. They're syntactic sugar over iterators, which are a really core concept in Rust. If you ever go through a collection of something or do something more than one time, you're using an iterator whether you know it or not. 0.100 returns not an array of 100 numbers. It returns an iterator that will iterate from 0 to 99. So if I'm not mistaken, this range here only takes up like 4 bytes because you only need to know one number instead of doing a full collection. But for loops look pretty normal other than that. And notice the lack of parentheses. You don't need parentheses in Rust around like if statements, for loops, or anything, which is kind of cool. You can loop forever by just using the loop keyword, and it will loop until it hits a break statement. This is pretty much like doing while true. If statements look pretty similar. You don't need parentheses around the condition. Of course, it supports if, else if, and else. Okay, so this is getting a bit more interesting. So vec exclamation point is a macro. You have a question?
Yeah, quick question.
Yeah.
Can you do the more traditional, essentially 3-parameter for loops in Rust?
Not really.
So how would that work for a non-obviously incremental for I guess?
Well, basically, lots of people go on somewhere and say, well, how do I write a for loop? I want to say int I equals 0, and then everyone says, what's your use case? Why can't you just use an iterator? And the person always says, oh, well, I can use an iterator for my use case, but I just want to know how to do this. And they basically say, there's no use case where you can't just use an iterator. Yeah?
Say you wanted to increment by 2 every time. How would you do that?
That's kind of what I was like, because like Python, for example, provides a way to do that in the iterator. Would that be how you do it here? Like in Python, you would do the slicing, so it would be like.
Right here now, x is an indexing variable by 2.
Okay, so you do that.
Yeah. There's other ways to do this that are a bit more rusty, as they say, but pretty much anything that you want to do, you can figure out a way to do it with the idiomatic Rust code. Yeah.
So are there? I'm assuming there are different ways to like define that range 0 to 100 to maybe get behavior along
Where it indexes by. So okay.
Or can you define? I mean, maybe not even like 0 to 2 to 4 up to 100, but like more, complex ranges, like something like a list comprehension.
Yeah.
Kind of thinking of?
I'm not sure.
Okay.
The answer is probably. They really packed a lot of functionality in here, but I think all of that type of stuff you would make a custom iterator and then define the functionality of your iterator. So you can. So if anyone's used Python generators, iterators can basically mimic that. So you make a new iterator, define the next function for an iterator. So then you can make an iterator that goes over the numbers, and the next function returns the previous number plus 2.
That's what's kind of getting at.
Yeah. Right. So you can do that with iterators, and pretty much any complexity that you want.
I was going to say there's a Rust crate that allows you to use the same Python syntax to make list comprehensions.
I actually think I've seen that.
Yeah.
Yeah.
Like a shooting crate or something.
Yeah, I haven't heard of that, but I'm sure it's out there. It probably makes use of macros. So sometimes you have code that you find yourself copying and pasting a lot that doesn't really make sense to put into a function. One thing that Rust does not have is functions with an infinite number of arguments, whereas Python and JavaScript, and I believe C, but I'm less sure about C, all support declaring functions with an infinite number of arguments. Rust, you can't do that. So you might use macros to accomplish that. I'm not going to walk through how you write a macro because it's a little bit more difficult than it is in C, but they're a lot smarter than C macros. The way C macros work is the compiler will find all your macros, find where you use them, and then copy and paste code where you invoked the macro, and then will compile. Rust doesn't do that. Rust is much smarter. So right here, the vec macro will declare a vector with 1, 2, and 3 as its elements. One thing that's kind of annoying that takes a little bit of getting used to is print line. So the print statement in Rust is a macro. So I often forget the exclamation point, and then the Rust compiler will say, you probably meant to put the exclamation point here. And of course it's right because it's always right. But the two macros that you're going to see the most often are vec and print line. Some crates depend a lot on macros and make really heavy use of them to write some really expressive code, but that's a bit out of scope. These are the two you're going to see most often for now. All right, so one great feature about Rust, which I am going to go into more next time, is that variables are immutable by default. So mutability of a variable means if you can change it or not. So in basically every programming language I can think of, except for Rust, values are mutable by default. Does anyone know another one where they're immutable?
Haskell.
Are they? I wouldn't be surprised at all if they were. It's a very Haskell-y thing to do. It's been said that Rust is like what C would have been written if it was written in 2010 by someone who only ever knew how to code in Haskell. And that's a pretty apt statement of how Rust works. So variables are immutable by default. So if you say let x equals 5, and on the next line you say x equals 6, that's a compiler error, which a lot of people do that, and then they exit Vim, CD out of there, and never touch it again. It's very unlike programming that you might have experienced. But if you think about it, why are variables mutable by default? Because there's really no advantage when you can just write MUT and make something mutable, and you just avoid accidentally reassigning a variable.
Wouldn't the common English vernacular definition of the word variable imply mutability?
Yeah.
I mean, if it's not mutable, then it probably shouldn't be called a variable. It should probably be called a label.
You're not wrong. I mean, that is true. But I guess we'll call them immutable variables, or just ubles, maybe. But
If your variables are immutable, why not just make them all macros?
Statables.
yeah, yeah. So the English language is at fault here, not the Rust language. We'll go with that though. But yeah, this can help you avoid some pretty simple bugs that you didn't mean to. And if you make a variable mutable and never mutate it, the compiler will compile, but it'll give you a warning saying, take off that MUT, you don't need it. Generics, of course, are in Rust. You use them with the standard angle bracket syntax like you might see in other languages. Here I'm declaring a vector of unsigned 8-bit values or bytes, and then saying it's a new vector. Functions are declared with the fn keyword. Then you write the name of the function. The arguments, you have to specify the types of the arguments because it's hard to do implicit type detection. And then you put this arrow operator and give the return type. So this function just adds the squares of arg1 and arg2. And you can see the comment. Notice the lack of a semicolon here. This is one of the most interesting features of Rust, and also is really confusing if you've never seen it before, because you're probably wondering why the hell there's not a semicolon at the end of that line. There's a good reason. And lastly, if you've used a switch statement in just about any language, Rust has those too. They're called match statements, however. Just replace this word match with switch, and it will probably make a lot of sense to you. Except in Rust, they're way more powerful because these don't have to be case labels. They can be patterns. So for example, I'm saying match x. If x is 5, we're going to execute this code. If x is even, so if x mod 2 is 0, we're going to execute this code. So this is a pattern. It's much more feature complete than just what you might have in a C case label. And if neither of these cases happen, we're going to go to the default case and print something else. For things that basically aren't bools or enumerable types, if you don't have a default, Rust will not compile it because Rust hates having people accidentally write mistakes. Also, there's no like implicit fall through in case statements because that's really never a good idea. I don't know why that's ever a feature. Maybe there was a good reason in like the 80s, but there's not anymore.
I actually use that once in Java.
It comes in handy every now and then, but usually there's just as good of a way to do it that doesn't use implicit fall through.
I don't really get the syntax of that second one, x if.
Yeah, so for example, if x is like a tuple value, then I could write this to basically name the tuple values.
Okay.
So this is what's known as destructuring, because otherwise, like, how would you? So basically, you're redeclaring the variable in a way that.
Was it necessary for you to say x if, or could you just say x mod 2?
I think it's gonna yell at me. Well, actually, I need to
What's the match again?
You
switch
actually don't
statement.
have anything to match against there.
I declare x higher up, I think. Wait, what?
You don't have anything to match it against in the second line now, so it'll.
It won't just evaluate this?
Wouldn't that be
Or-
There's nothing. There's no pattern.
Yeah,
The
yeah.
first one is just 5.
Yeah, I think like patterns have to start with a variable. I'm really not sure. It's going to yell at me though. Yeah. So expected a pattern, found a keyword if. There's in the Rust book, they go into pattern syntax in detail. I haven't read that chapter, so I'm not sure the formal definition of a pattern, but looks like it needs something there that's not just if.
without the if. X mod 2 is 0.
Just like this?
Yeah, like that.
Oh, that might actually work. Well, no, I don't think it'll work because I have equals there. Yeah, so it doesn't understand equals. It expects one of these. This is a guard. We have if. This would be right here, and I'm not sure what the at is.
Thank you.
Yeah. All right, so I think this is a good stopping point. What time is it? 8:05. Oh, perfect. Okay. Does anyone have any questions? Yeah.
Other than the compile time being a little long, what are some other like cons? Or
Cons? Yeah. So the syntax can get ugly. I didn't show any ugly examples here, but if you have like complicated code, you get really, really ugly syntax. It just is really hard to read. The learning curve's super hard. It's hard to get started on the language. They're working on that. Compile times are slow. Other cons? No, it'll be sometime in the future. Yeah. There's some other cons that I'm not thinking of right now, but those are the big ones. Is syntax. It's a relatively new language. It's slow to compile and hard to learn. Yeah.
So I asked this because this is a pain point I've been having with Python recently. Does Rust have a nice way to do bit level manipulations
Oh,
of
yeah.
integer values?
Oh yeah.
It's like in Python, the solution I found is like cast it to a string and then use string slicing.
Yeah.
Cast it
No.
to a
Rust handles that very nicely
It's like
out of the
I can
box.
go, I want the fourth bit out of this int, and it actually has a way to do that.
So there's a really popular crate called bit flags. It's actually, I think, the most popular crate on crates.io, and I'm pretty sure this does what you want. And I think it's a wrapper around libc's bit flags implementation.
Python does have bitwise operators, but you can't subscript at bit level.
Well, once again, thank you so much, Jeremy. These talks take a lot of work to get going and like put them together. And Charles, shut up for a second. Yeah, these talks take a lot to get together. There's absolutely no reason that people do them besides wanting to let y'all learn something today. I don't know about y'all. I had more language experience learning about Rust. That was incredible. But yeah, thank you.
Yep. Thank you.